My talk starts talking about the vortex effect in PCNL, which now we did some research, and then try to elaborate after the introduction. How can we uh, how what we learn from a mini perk vortex effect, and how can we use doing a flex ureteroscopy with suction. So as everybody know, mini perk now is very popular because typically, decrease pain and transfusion rate and hospital stay, and it has really, really good efficiency in terms of stone-free rate. So really nowadays, from all my PCNLs, probably more than 90% are mini perk. So um, one of the effects that really turned the mini perk into very popular is what we call the vortex effect. And first was introduced by this author Nagel, and he called a vacuum cleaner effect. So when I think about vacuum cleaner, in my mind and probably in everybody's mind, it comes with negative pressure, right? It's a vacuum. You think about negative pressure, but obviously on mini perk there is no negative effect, no negative pressure inside the system. So I talked to my team in the lab and we tried to further understand why what we call the vacuum cleaner effect or the vortex effect works. And that's how we develop a system and a model in our lab, and then try to understand better. So there is some theories. Hold on. Sorry, let me just get you. Sorry, guys. There we go. So what we did, we designed is called we designed a model that was the same model as the same geometry of the mini perk set from core stores with a 15-16 French axis sheet and a 12-point French nephroscope. And then we did that in a transparent mode, like using acrylic. It was not glass, it was another type of material, but we could see inside. And then what we did, we used saline as the flow, and we put a couple wires to run electricity there that do the hydrolysis, so we can see the bubbles. And then seeing the bubbles, we shade a light, a laser light, like a green light, so we can see the bubbles better, so that we can understand how the vortex effect works. So this is our model here. So you can see that will be, the kidney. It will be like the axis sheet, and that will be in the nephroscope. And then we shade this, laser light so we can see better the bubbles during hydrolysis, since we run like a little current through wires. So that's how we create the model. And it was very interesting because we could see really the bubbles and how the flow works. So basically, what happens when we start, in we start the flow through the nephroscope. I would say there is create what we call annular area, and then there's recirculation area, and then a stagnation point. That's what we found during our process. So it's interesting that here, after this, what we call stagnation area, there's really no motionless, like no fluid going further than that area. So that's what we call the stagnation point. So there is what we call the intrusion portion, which is between the nephroscope tip and the stagnation point. So after we did that, we could really calculate the flow rate, how much it goes out, how much stays in, and then the pressures within the system. So what we found that immediately after we introduced the nephroscope, 1/3 of the flow just goes out, and then the rest goes in to the stagnation point. And then we could calculate the pressure at the tip of the nephroscope and then the stagnation point and see the pressure. And there's really the gradient of pressure that really brings the stone towards the nephroscope. So if you think about Bernoulli's principle, the fastest the speed of any fluid, the less pressure on that point. So if you think about the nephroscope, the the tip of the nephroscope where the flow is coming out is the area that has high speed of the flow, and therefore there is less pressure on the system. And then the stagnation point inside the kidney is the point of the system that has less speed of the flow and has high pressure. So this gradient in pressure really brings the stone towards the nephroscope. And here's that part. So sorry, I'm getting some problems with my. Okay, so flow is the number one, and then the splitting, as I said, which is so 2A and 2B. The 2A goes onto the between the nephroscope and two-thirds going, we call the 2B. And there is the point, which is the point of maximum pressure there. And then there's no speed at that point. That's why it's the maximal pressure. And then obviously no evidence of fluid coming to the collective system. Um, and then when we run some pressure measurements, we saw that on number 2, with the stagnation point, and number 1 is the nephroscope, and this is the difference between one versus the other. We really generates the force necessary to move the stone towards the nephroscope tip. So what we learn is that what is and the between access sheet. I mean, use your 12.5 inches from Carl stores, and if you 15, 16, it works if you use 20 feet in the same nephroscope. It's because it's about the nephroscope size or the sheet size between the nephroscope and also about the stagnation point inside the system and the pressure within the tip of the nephroscope that creates a vortex effect. So if you think about the fluid speed, uh, and once you're doing a lot of mini perks, you understand there is a perfect speed that you have to retrieve your nephroscope in order to get the stones out. If you do too fast, that vortex effect stops. And if you do too slow, obviously you can do it, but that becomes a little, cumbersome. So once you keep doing a lot of mini perks, you understand there is a perfect speed to retrieve your nephroscope in order to remove the stones. Why that happens? And also, we are thinking about, people who does supine PCNL and people who does prone mini perks. What's the difference in terms of angulation and gravity in terms of, interference with the vortex effect? So what we did then is to create a model to try to understand the speed of the nephroscope and what's will be the perfect speed to remove the nephroscope in order to retrieve the stones, and also study the angles of that. That will be important if you're doing a supine PCNL versus a prone PCNL. So we create this model as a bench study. We use accelerometer to attach to the nephroscope, so we could really uh, uh, evaluate the speed of the nephroscope. So here our model, and here is in 0 degrees, here in 45 degrees, and here in 9 degrees. And here's our bench study that we put small stones here on the system, and then we see how you're retrieving the stones with the nephroscope. Here's in 45 angle, so you can see the stones coming out. and here is a 90-degree angle. And you can see again, I'm gonna pass the clip again, see how when you're doing in supine position or in 0 degrees, how the retrieval of the nephroscope is faster than when you're doing 45 degrees versus a 9-degree. That's why probably the supine PCNL is typically more popular than the prone PCNL. Again, the same approach. You can see difference in terms of speed retrieving the stones. And here are numbers. If you're using the nephroscope in 0 degree, which is surrogate for supine PCNL, you do pretty much, you retrieve your nephroscope at a rate of 5 centimeters per second, compared to only 2.6 centimeters per second in 45 degrees and 2.5 centimeters per second in 9 degrees. So really, gravity plays a role here. It's not that the vortex effect doesn't work on 45 or 9 degrees or in prone PCNL. It's just a matter that you have to retrieve your nephroscope slower than when you do doing supine PCNL, about a ratio of times 2. And here's how we calculate the time that we spend to remove all the stones that we put in our model. And here, obviously, 0 degrees, it just takes less than 30 seconds to remove everything. And compared to the other ones, there it takes more than 100 seconds. So why that happens is, if you think about it, the flow goes, the inflow goes this way, towards the kidney, and then you're retrieving your nephroscope backwards, right? So if you think about the relative velocity or relative speed of the flow, once you retrieve your nephroscope, what you're doing, you are decreasing the speed of the flow relatively, because you're removing the nephroscope the other way around. So what happens then, the flow start going slower and slower and lower as you retrieve your nephroscope, to the point if you retrieve too fast, the flow will stop, and then you stop the pressure gradient that retrieves the stone. That's why you have to have like a perfect speed to retrieve the nephroscope, so that relative speed doesn't decrease too much that will interfere in the pressure gradient. That's how that works. So far what we understand on that, after we published this paper and then present some videos on major conferences, that the vortex effect is better labeled than the vacuum cleaner effect, because there is really no pressure, no negative pressure detected. It's intrinsic for mini perk technique, is better, obviously the mini perk, but can also be seen on other, on regular perks. It depends really the ratio between, the nephroscope and the Excel sheet. The flow patterns explain the physical principles. So the main component is the pressure gradient, and it's regulated by the fluid speed, and the fluid speed is regulated by the flow rate, the equipment geometry, and more effective in smaller sheets with the same nephroscope. That's what we found so far. It's better, obviously, in supine, but also can be done in prone position. The gravity plays a role, but it's not really interfere to the point that cannot be done in prone position. So that's what we know about vortex effect in mini perk. Okay, let's talk about ureteroscopy. Okay, so having some issues with the. So if you look at the AUA and EAU last year, you saw so many, abstract was published in terms of suction in your Excel sheet. So it's really a big topic here. And then, all the other, participants, we're going to talk about it. So, and I would be really fortunate to be one of, the few that use the Cleopatra sheet here in the US. We are probably the first one that we used once start distributing. And probably everybody's aware of the Cleopatra sheet, but basically it's a Urex sheet with a suction possibility. Here's a canister. Here's how we set up the sheet, after we place into the patient, and then obviously there is this part of the sheet that is, malleable, that what we call the fans now. then you can really access pretty much every calyx. Obviously, depends of the configuration of the collect system. But really now becomes very popular and to in order to do a better a better uroscopy. To gain access is pretty much the same as a regular sheet. We put a wire, we pass a sheet under fluoroscopy, you know, and then we retrieve the obturator, we connect our scope, we connect our suction, and then there is this catheters. There's a little valve that you can connect also through that you can control the pressure, and then you go, around the system, and then when you find the stone, you just, advance the sheet through the Ureteroscope and then do your lithotripsy, and hopefully small fragments will just go outside without need of basketing. This is another great video when you're doing, when Dr. Sobel from West Virginia, you're doing a mini perk, and then he used the sheet, so you can see how malleable is the sheet within the collect system. So it's really great to navigate everywhere. So it becomes very popular, those fans. Here are on video. I think it was probably Dr. Wiles, my partner, who is probably watching us now here, doing a flexible uroscopy with the sheet. So we park the sheet at the tip of the, the stone, and then start using the laser. And if you're lasering well, and then you can, debate which laser is the best. But here is not the point. It's really to try to decrease the size of the stone so well that we can do what we call passive suction, meaning you don't have to remove your uroscope. So just small, fragments just go by and makes things really faster. So you can see, you just keep lasering and stones just keep coming out. So, but obviously, and then here you can control, his Dr. Y is controlling the suction by, occluding the vent, the pressure vent, so you can get more and less suction. And again, just try to keep working on your irrigation and your lithotripsy. However, there is larger fragments that you can retrieve what we call active suction while we are retrieving the uroscope. And this is really similar to the vortex effect, right? So basically, it's the same as we found on a mini perk. However, the geometry is completely different because there is a difference in the ratio of the axis sheet and the uroscope, and also because we have now a vacuum device together, and also because the length of the axis sheet is way longer than the length of the sheet for mini perk. So those things are not studied yet. This is a case that I did myself, using the sheet. Everybody, already had a case that really when you go in, there is hundreds of little pebbles that you can even basket, you can even laser. And then this is the perfect case for sheets that contains, suction, because, that case I didn't even laser it. I just sucked them out. So that's a perfect case for sheets with suction and navigation. Ben and Olivier participate on this trial, and recent published last year that show that there is really significant stone-free rates when you use vacuum access sheets with minimal really complication. However, there is no RCT in the US at this point, and I'm really proud to announce that we start our prospective randomized trial between, using vacuum cleaner XHG versus the traditional approach. And I want to really thank Carl Storrs to be the sponsor for this trial. And we are about to start enrolling patients, and hopefully in a year or so we can show our results on our on RCT. So after using, the axis sheets for uroscopies, and after, doing the vortex effect lab trial, things that we learn, that suction itself does not work without inflow. So inflow is better. If you don't have any flow, there's no suction in access sheets. The fragment remove is dependent on the adequate flow rate. If there is not a good flow rate, it's hard to retrieve a fragment out of the access sheet. So anything that changes the flow rate impacts the fragmentation removal. So if you think about occupancy, the work channel, if you have a laser inside the working channel fiber, so think about removing if you feel there is no retrieval of the stones when you're doing active retrieval. The inflow must be continuous. So if you're using any type of handheld devices like single action pump, etc., when you're using access sheet with suction, it doesn't really not work. So you gotta use a continuous flow. And Steph is gonna talk about the ZSR system about that, but gotta be an inflow that must be continuous, cannot be intermittent. And there is really a balance between inflow and outflow that really makes the magic happens. So at University of Kansas, what we do, we pressurize a bag of 150 millimeters of mercury, and then we have the suction on 120. That creates that 30 millimeters of mercury gap between one and the other that really uh, it's perfect for stone retrieval, and it still doesn't collapse the collect system as well. But now, once we, go modern area, then Steph is going to talk about those systems that really can control automatically the in and outflow. Really, it matters is like, you work in an environment that is not collapsed, but good enough to retrieve the stones. And the speed of the retracting the Ureteroscopy is really similar to the vortex effect, as I show in the video. But unfortunately, at this point, we have not studied yet the hydrodynamics of this. So what's unknown yet? So how the suction impact the fluid dynamics and constantly the vortex effect? How does the longer and flexible Ure sheet impact the flow rates and the vortex effect? Those are unknown topics. And new bench studies with suction and longer sheets needs to be done to investigate, and I start talking to staff about that. And hopefully we can collaborate also with Ben, with Dr. Gower and everybody else to better understanding the dynamics of the fluid during uroscopy with the suction device. So here I will stop, and if I have further questions, I'm happy to answer them.